Hey everyone, Mr. Skelton back at it here for lesson 2 in unit 3, which today we're going to be proving lines parallel. As you look over your notes, you're going to see a lot of familiar vocabulary, and you're going to be thinking, how is this different from the lesson we just did, right? If you look at the key concepts here, you see corresponding angles, right? We talked about CAs already, alternate interior angles. We talked about AIAs already, same side interiors. And hopefully when you're saying these and writing these down, these little abbreviations of the words, you're thinking about what they mean and what you learned in Unit 1. So you're probably wondering, what are we learning today? How is this different? Well, in the first lesson, you may recall that, I'm going to use some space up here, I kind of taught you that when you have two lines in geometry and you have these little triangles on them in red, do you remember what those little triangles mean? They mean that the two lines are parallel. And in lesson 1, every situation where we talked about CAs, AIAs, and SSIs, the lines were parallel first. And you may not remember that, but if you go back and watch the video or look at the examples, you'll see these little arrows on all the problems. And so in lesson 1, the theorem stated, if lines are parallel, then CAs are congruent, AIAs congruent, SSIs. And so today, you can see each one of these starts with the converse, and that should be a familiar word with you, or for you. We did conditionals, converse, inverse, and contrapositives. And so down at this very bottom in this empty space, I'm going to kind of recap what we did in lesson 1. So I'm just going to put a number 1 for lesson 1, and I'm just going to simply write a conditional statement from lesson 1. If two lines are parallel, then I'm going to write 3 situations. CAs are congruent, AIAs we know are congruent, and what about SSIs? Do you remember about what SSIs mean? They mean equal to 180 degrees. And so this was the conditional statement. There's your if, right? And there's your then. And so this is what we said in lesson 1. Two lines are parallel, then the following are true. Well, today we're just doing the converse of that statement that I just wrote. You can see, if corresponding angles are congruent, then the lines are parallel. If alternate interior angles are congruent, then the two lines are parallel. Same thing with SSIs, equal supplementary, then the two lines are parallel. So today we're showing that lines are parallel, and the way you do that is by checking to see if you have corresponding angles that are congruent, or alternate interior angles that are congruent, or if you have a situation where same side interiors equal 180. Okay? Alright, I'm going to flip it over on the back, and we're only going to do one of these proofs. We're going to do the one on the left here, and there's a little typo on your notes here. This right here, this 1 should be a 7. So if you make that a 7, that will help yourself out there a little bit. So this is a good proof. We've done some proofs with algebra. This is a proof of a theorem, actually. And I just want to start out by saying that remember that reasons have to be either definitions, like definition of a midpoint, or definition of an angle bisector, or definition of a perpendicular bisector, or they can be theorems. Theorems are like vertical angle theorem, right? That's a theorem. They can be postulates. Okay, postulates like angle addition postulate. Those are all things that you can place on these lines. You can't put stuff like, because it looks like it, or I said so, or, it just looks that way. They have to be reasons, okay? They have to be mathematical definitions, theorems, and postulates. So let's jump into this proof here. We want to prove that L is parallel to M. And so what we have here is 1 equals 7, and we know that from the given information, so we'll just write given. Now, look at statement B, 3 equals 1. Look at the picture. How does 3 equal 1? How do you know that? We know that because those are vertical angles, and we know from the vertical angle theorem that vertical angles are congruent. Okay? Now, part C, you got to do a little bit of thinking here. If 1 equals 7 and 1 equals 3, then 7 equals 3. And do you remember that property? That's like the one property we talked about, like if Homestead beats Carroll, and Carroll beats whoever, then Homestead should be able to beat those. That's the transitive property. Okay? All right. So we have the transitive property there. And then if you look, we have 3 equaling 7. So if 3 is equal to 7, we just showed that 3 and 7, which are corresponding angles, right? Lower left hand or lower right hand corner and lower right hand corner, then we know those are congruent, or we know that these are parallel by the converse of corresponding angles theorem. Okay? We just showed that 3 and 7, which are corresponding angles, we just showed that they are congruent. Therefore, now we can say that those lines have to be parallel. Okay? We're not going to do this proof over here. We're just going to jump down and do some examples. Now, you'll notice on these 4 examples, they look almost identical to what you did. I'm going to zoom in just a touch here. Almost identical to what you did in lesson 1, and that's a good thing. It's just more practice at these. So let's go through these. And it says find the value of x that would prove that the lines are parallel. So you're looking for either corresponding angles, AIAs, or same side interiors in knowing your knowledge or knowing what you'd learned from lesson 1, kind of setting up the problem the right way. So let's take a look here. Okay. First of all, you have this angle, 6x plus 34, and then 9x minus 2 there. How would you classify those? Are those CAs? Are those AIAs? Are those SSIs? Right? That's the biggest thing you have to come up with first. And hopefully you can see that those are alternate interior angles. So we know that alternate interior angles are congruent. So we're going to set it up and solve for x. Minus 6x, add 2. 36 equals 3x, divide by 3, and x equals 12. Okay. Down here at the bottom, the one right below it, number 2, this one a lot of students get a little confused on. They see this 3x plus 20, which is technically that angle there, and here's your 5x right there, and they're looking at those saying, those do not look like corresponding angles. They're definitely not alternate interior angles, and they're not same side interiors. So when you get that, you may have to move some stuff around a little bit. What I mean by that is this. I can use vertical angles, right? You would agree that these two right here, where I'm going back and forth with my pencil, those are vertical angles. So technically, this is 5x as well, because if this is 5x, that has to be 5x. So now if you do that, and you kind of cover that up and focus on those 2 dots, how would you classify those? Well, those are corresponding angles. So we know corresponding angles. We're going to assume, because we're trying to prove that the lines are parallel, we're going to assume that these are congruent to each other. Okay, and solve for x. Because we know corresponding angles are congruent. Divide by 2, and x equals 10. Okay? I want you to go ahead and hit pause, and I want you to try the 2 right next to it, and then when you're done with those, check back with me. All right, we're back. Again, setting up, we're making some assumptions based on the position of the angles. We need to classify them first. Are they corresponding? Are they alternate interior angles, or are they same side interiors? And if you look at these 2 here, those are just like the one we just did at the bottom. Those are corresponding, so we know 55 equals 3w minus 2, and then we would just add 2 to both sides. That's going to give us 57 equals 3w, and we're going to divide both sides here by 3, and we get 57 divided by 3, which is 19. Okay. This one down here, some of you may not like how this looks, right? Because we're used to seeing the 2 parallel lines go kind of left to right, and so if you want to, you can kind of turn your paper. I used to do this as a student all the time to make my picture always look very similar. Here's your 2 angle measures, so I'm kind of putting dots there. Again, you have to classify what type of angles. Are those corresponding? Are those same side interiors? Or those alternate interior angles? You can see when you flip it sideways, those are SSIs. Most common mistake is people want to set these equal to each other. Remember that SSIs add together to make 180. All right. So put my like terms together. That's going to be 33x. I'm going to minus 15 from 180. Okay, which should be 165, and I'm going to take 165 and I'm going to divide it by 33, and I should get x equaling 5. Okay? So the problems you're gonna do in your classwork today, obviously you can see are almost identical what you did for classwork yesterday. The biggest thing that I can get across to you is that in today's lesson you're proving that two lines are parallel. You don't know that they're parallel to begin with. You're using your knowledge of corresponding angles, alternate interior angles, and SSIs to prove that. And that proof, you may see this again on a quiz or a test come up. Whenever you see this statement right here, prove that two lines are parallel, you should immediately be thinking that has to be the converse of something, whether it's converse of corresponding angles, you're based on the location of 3 and 7, or AIAs, or whatever the case may be. But that's a big key as you move forward with proofs. Is for this one, proving lines parallel, it's the converse, okay? Because all three of these say converse, 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 and they all end with then lines are parallel, then lines are parallel. So takes a little bit of time to get used to that verbiage, but hopefully over time you get there. All right? We'll see you in class, and good luck on your classwork.